So question 12 in chapter 6.2. I have to say this is a brilliant little question. I was a long time looking at this, scratching my head. We'll get into the breakdown of it for a second. So it seems quite a simple question to start off. You're told that 5 discs fit exactly into a rectangular frame of width 20. So we know the width. It says find the area of the remaining space. So you don't know this distance here, okay? This is what you're trying to find. If this here is 20, then we know that this here line, which represents essentially it represents the radius again, another radius, and another radius, that our radius has to be equal to 5. Then 4 radiuses into 20 would give you 5. So R is equal to 5. So you can find the area of the 5 discs fairly quickly because the area of one disc is pi r squared. You got to multiply that by 5. We know that our R is 5 as well. So 5 5s are 25 by 5 is 125 pi. And you're flying and you think you're going to do this question and then you hit a bit of a roadblock. And I'll be honest, I was a long time trying to figure this out. I'm just going to rub out this line again before we go any further. And like once you see how to do it, you can't but see how to do it. But until you see how to do it, you can be staring for a long time trying to figure out what's going on. So, I mean, the obvious thing was when you're trying to find out that distance, you know this distance x, you can say, well, I know from here to here is 10. It's 2 radiuses. And I know that similarly down here is 10. So I really need to find out this little bit in the middle. So you're questioning yourself going, how can I find this bit here? That would be a mistake to draw these two lines, and I did that, and it probably was a mental block on me for the rest of the question. It wasn't until I decided to draw all the other lines I thought were important did I go about solving the question. And what are the important lines? Well, sorry, I'll write these lines back. There's an argument to say that they're important. But every line that goes through the center of the circle as you move down this way here, because this is the distance we're trying to get, all those lines are important. When I had the question set up like that, I suddenly twigged, I know that it's 5. So why don't I just focus on trying to find this distance here? So I'm trying to find from here to here, rather than trying to find previously, I have been trying to find from here to here. So let's get rid of the lines that aren't important now. That line is not going to be important. That line is not going to be important. This line is important. I'll just redraw it because it's important. So now this little bit here, this little line here, when we have two circles that are touching at one spot only, the line that we draw down between it is a tangent to both. Sorry, the perpendicular that comes off it is a tangent to both. So this here is 90 degrees. The tangent, the perpendicular comes off it, runs through the center of the circle. Perpendicular that runs off the tangent goes through the center of the circle. Now, you might note that the center of the circles, let's say I'm not drawing this with a ruler, but these are all collinear, meant to be collinear. So I have this triangle forming here. Or I could focus on this one here. I have these triangles forming that is going to allow me to find this distance here that I've been missing using Pythagoras. So using Pythagoras, I can say, find out that distance, I'm going to call it y. So 2r squared is equal to r squared plus y squared. So you're getting 4r squared is equal to r squared plus y squared. This comes across, you're getting 3r squared is equal to y squared, which gives you y is equal to the square root of 3 times r. So we now know the distance from here to here, and that's going to be the same as the distance from here to here. And then we've got to add on 5 both sides. So we go and look at our length, our x as we called it at the start. Our x is going to be equal to 5 plus 5, the 2 bits outside, and then 2 times the square root of 3 times r. Okay, there's one of them, and there's the other, so it's 2 times the square root of 3. So from there's the square root of 3r, and there's also another square root of 3r. So we've got 2 of them. So x equals 10 plus 2 times the square root of 3r. So now that you've done that, you've got to find the area of the rectangle. So it's x by y, length by width, x by y, or x by 20. And we know that x is equal to 10 plus 2 times the square root of 3r. Got to multiply that by 20. You're getting 200 plus 40 to the square root of 3r. So you've got to subtract, where is it? There it is, 125 pi minus that. So we know that our r is 5 as well. So just tidy that up. 200 plus 40 by 5 is another 200. 200 to the square root of 3. So take one away from the other. I don't have a calculator here, so I'll let you work this out yourselves. But 200 plus 200 to the square root of 3 minus 125 by pi. So whatever that is, you get your answer.